the computers in our lab, have a look at the back of them and see how many LAN ports there are. Everyone have a look at the back of their computer now. How many LAN ports? So identify the LAN ports. You should see there's a cable plugged into one of them, a yellow cable, and there's two that have nothing plugged into them. Right? These computers have three LAN ports, three wired LAN ports. One is on the motherboard. All right? The yellow cable is plugged into the LAN port on the motherboard that comes with the motherboard. And we've bought two extra PCI cards plugged into the PCI slots for extra LAN connections. So we'll use three of them over the next few labs, not today. By default, we'll use that one on the motherboard, and we'll use the other two for some special purposes later. So these computers have three wired LAN ports. Any other network interfaces? Wireless, okay. We've got a USB wireless adapter here. So in fact, we have four network interfaces. Three wired interfaces and one wireless interface. And there are no others on these computers. Where does the yellow cable go to? There's a yellow cable plugged into one of the network interfaces. Where does it go to? Can you see that? In this lab, we can do things to find answers. You won't break anything. If I say, where does it go to? Have a look at the cable and see where it goes to. It goes to the floor. Doesn't it? And then where does it go? You see it plugs into this special adapter in the floor, and you notice, I think, that the floorboards here are raised. They're about 20 centimeters above the actual floor, so we have a raised floor here, and there's cables underneath to make the layout a little bit nicer. So they go into a socket on the floor, and then a special extender cable that goes under the floor and into these four cabinets in the corner. You can maybe open the door in the back cabinet and open this door, and you'll see if you open that one, they'll see, and you can look at any time, the four groups of 9 computers go into one of the four cabinets. So these 9 computers, the cables from the floor, all come into the cabinet here. The 9 green computers go into the cabinet there, and you see in the yellow one at the back, you see all the cables plugged in there. Look in those cabinets, if you can see, it's not easy. How many devices in there? You should see there are 4 devices in a rack there. Okay. The cables are plugged into just one of them, I think the bottom one. That's a switch, right? So that's a network switch. The cables from the computers plug into that switch, and then that switch has another cable that goes upstairs to a 5th switch. All 4 of these switches all plug into that 5th switch upstairs. Then that one connects out to our router for SIIT, and then out to Rungsit, and then out to the rest of the world. So that's the topology of the network. This picture's a little bit old. It only has 3 devices in the cabinet, but our computer has a cable, not 2, just 1 at the moment, going into the floor. Under the floorboards, it runs into these cabinets. In the cabinets, you'll see we're using 1 switch. That's all we're using at the moment. But there are 3 other devices there, and the top 2 are routers, special purpose routers, and the third one is an old switch. So the one we're using is the newer switch of those. So the top 2 are routers. So if we wanted to connect and build up an internet, we would use those top 2 devices. In this course, we will not use those other 3 devices. Because it's hard to get access. It's hard for students to walk up and plug cables in. So we will use our own computers as routers in later tasks. So that's just the physical topology of our network. We have 9 computers connected into a switch, and those 4 switches connected into another switch. We're all on the same LAN, all on the same subnet. And in fact, the Mac lab upstairs is also on the same subnet. So from the internet perspective, we're all on one big cloud, one big subnet for this lab and the Mac lab. So we want to learn some commands that show us more information about our network setup. So we said how many wired interfaces? We said we have 3 wired interfaces and 1 wireless interface. What's a command that shows us the configuration of our interfaces? Try the command that I've used and shown you many times, how to see the config of your interface. Short for interface is IF. ifconfig. Show you the configuration of your interfaces. And for me, I'll just pipe mine through less so that we can scroll through. You don't need to. So this shows you from the operating system perspective what interfaces this computer has. And you note some names there, ETH0, ETH1, ETH2. ETH short for Ethernet, the common name for wired interfaces. So there's 3 interfaces for the wireless cards, the wired cards, sorry. LO, what's LO? Local or loopback. This is a special interface for testing when you want to send to yourself. So this is not a hardware interface. This is a special one set up by the operating system. If you want to send something to yourself without sending out on a cable or a wireless link, you can send to the LO interface called the local loopback interface. And you may recognize the IP address there, this special case address, 127.0.0.1. So that's a special case interface. Where's the wireless interface? Can everyone see theirs? No. You can only see your 3 wired interfaces. ifconfig doesn't show interfaces which are turned off. If you want to show all interfaces, use ifconfig -a. Show them all. And you should see WLAN there, wireless LAN interface 0. You can plug in multiple wireless LAN adapters and you'll get, usually the operating system, we've set it up so it labels them 0, 1, 2 and so on. And the way that we've set up these computers is, assuming everything's correct, ETH0 is always the network interface on the motherboard. This is a useful one to remember. ETH0 is on the motherboard. ETH1 is the top PCI slot. ETH2 is the bottom PCI slot. Right? 0, 1, 2 physically. Because later when we plug cables in, we'll need to know which one we're using. So the operating system gives them names. If we want to look at just the config of one of them, we can specify ifconfig ETH0. Another tool is, so this shows the operating system's perspective of this interface. We can also get a bit of information about the hardware. So it's actually a piece of hardware on your computer, and one tool that gives us something about the Ethernet hardware is ethtool. Followed by an interface. It tells us some information about that hardware associated with ETH0. And I'll pipe it through less because I know it has a lot of output. So that's some information about the hardware device. ifconfig is about the software configuration. Have a look through that information. And try these 2 tasks. See if you can find some of the information I list there. So just from those 2 commands, They give some information, just browse through. You don't need to understand everything, especially from ethtool, but some of the things you'll quickly recognize. And especially look at the output of ifconfig and see if you can complete these two tasks. Find the information, then put a file on my computer named by your computer number. Bonus for the first person to do it in a short time. So we're trying to find some information, very basic information about our LAN interfaces. And to find that information, two commands you can use. First ethtool, followed by the interface. I'll pipe it into less. Tells us a lot of information about think of the hardware and the link. What data rates are supported by your wired LAN interface? What data rates are supported? Well, it says there are different link modes supported, and we see these strange names, but you may be able to guess 10 base T half, 10 base T full, 100, 1000. 10, 100, 1000 are the data rates that Ethernet support. Our device, so the hardware can send at either 10 megabits per second, 100 megabits per second, or 1000 megabits per second. The base T is just the name given to the type of cable or the connector here. Half and full refer to duplex. Half duplex or full duplex. Half duplex you can send in both directions but one at a time. Full duplex is typical today where we can send in both directions at the same time. So this is what's supported, because when you buy the device, it supports the old 10 megabits per second, the less old 100 megabits per second, and the current typical device, or the speed for your device is 1 gigabit per second. And the way that works is that your device advertises those capabilities to the other endpoint of the cable. The device at the other endpoint, they do some negotiation. So auto negotiation means they will automatically try and choose the best one based upon what both endpoints support. Because if the partner only supports 10 and 100, and you support 10, 100, or 1000, you cannot use 1000. You'll use the best that both support. Well, it turns out both of them support 1000 base T full. We support 1000 base T full. We advertise that to the other side, and the other side, the partner, advertise that as well. So that's what we use. That's the best one. How do we know what we used? The speed tells us. 1000 megabits per second and duplex is full. Try not to resize your windows. Duplex is full, speed is a current data rate. So they're the two main fields we care about here at this stage. The other one, which wasn't the question there, the very last line is very useful when we do some real testing. Is the link detected? Yes. What if we look at ETH1? Link detected? No. We don't have a cable plugged in and there's nothing at the other endpoint. So this will become useful because sometimes we'll plug a cable into the wrong interface, or we don't plug in the other endpoint. So a quick check, is the link detected, yes or no? So that's useful when you're setting up the links. ifconfig. Tells us our hardware address. And the hardware address, where does that come from? It's the MAC address, that's the other name, or a physical address. Where did it come from? The manufacturer. So the company that made the chip on the motherboard, or the PCI slot, assigned this hardware address to it. It should be fixed and unique. This is the IP address. In my case, 10.10.16.201. This is assigned to your computer, so this may change, whereas you can think the hardware address is fixed. It's for the device. This is assigned to my computer. Where did that come from? Who gave it to me? How did your computer get this IP address? Well, there are three basic ways. Either I set it when I start my computer. I manually set the IP address. I did not do that. I think when you boot your computer, you didn't type in the IP address. That would be very inconvenient, but we can manually set it. We could have a file on our system that says when the computer boots, load this IP address, a static address. And the third approach, which is more commonly used, is that when our computer boots, it asks a special server, can you give me an IP address? What protocol does it use to ask a special server for an IP address? D, we need to configure our hosts dynamically. Dynamic Host Configuration Protocol, DHCP, is the protocol that my computer asks the server, give me an IP address, and the server says, here, use this one. We will see that in a later lab, DHCP. It also gives me this other information, and you know you're experts about broadcast addresses, network masks, and from that also you can work out the network address, which is 10.10.16.0 in this case. The way to work it out, look at the internet address, grab the first 22 bits, Y22, 255 is 8 bits, 8 ones, so there's 16 ones. 252 is in binary, 6 ones and 2 zeros. So we have 8 plus 8 plus 6. Grab the first 22 bits of this binary address, set the last 10 bits to 0, and you get 10.10.16.0. So that's how you get the network address. This is your IPv6 address. We're not using that in the lab in this course, IP version 6, but most operating systems give an IPv6 address to your computer. But in this case, it can only be used on the local LAN. It only has a scope of the link. It can't be used out on the internet. The rest are some statistics or status information about how many packets have been received, how many bytes have been transmitted since we started the interface, usually since we've booted the computer. So we can get a few stats plus the other information about the addresses. Let's stay with those tools and a couple of others briefly. ethtool also gives us some stats. Minus S. ethtool minus uppercase S gives us some statistics. Not much different from ifconfig. So sometimes when we're running our network, we want to diagnose if something's gone wrong. Maybe look at how many packets have been sent or how many errors have we got. We shouldn't see many errors. If we do, we see thousands of errors, then maybe there's some problem with the hardware or the cable. So ethtool has many options, in fact. We can see statistics with uppercase S, a little bit out of the scope, but we can also change parameters using ethtool. I don't think we'll do it very often, but we can use ethtool to set a value from our ETH0 interface. I can set the speed to be 100 megabits per second and the duplex to be full. So mine was set at 1000 megabits per second, duplex full. If I want to change the speed, maybe for testing purposes, I want to slow down, I can set it to a specific value. When we run it, it says operation not permitted, because many networking things, we can view the information, but we're not allowed to, as the normal user, change the network settings. So what do? We do this as super user. And I've set up these computers so that the student user is allowed to run most networking commands. And if we check now, we notice the speed is 100 megabits per second. We should set both speed and duplex together because they go together, the speed and duplex mode. You get an error if you try to just set the speed. And ethtool has many other options. I'm going to set mine back to 1000. So to see statistics, we've got ethtool, we've got ifconfig, plus the other configuration information. Before we have a break, another way to see the statistics, there's a command called netstat, network status. And it has many options, netstat. It produces lots of different output, depending upon the option we specify. To see statistics, -s, lowercase s here. So the options don't always mean the same thing across different commands. In ethtool, it means set. In netstat, it means statistics. If we wanted to get statistics in ethtool, it was uppercase S. So that's a bit confusing. Try netstat -s. Gives us some network status information, in particular some statistics. I'll pipe it into less because there's a lot of output. And here are a lot more details of all the IP packets I've sent. Any with errors or different types of packets. ICMP is used for ping, so all the ping messages being received and sent. The different types of ICMP messages. TCP and UDP are transport protocols, so it shows some statistics about TCP and UDP, the connections opened, segments received, errors. So if you diagnosing problems, looking for statistics about the error messages received can be useful sometimes. And some extensions of UDP and TCP, some further statistics for extensions. So some of that we may not know what they mean, but if you want to find detailed statistics, netstat -s. When we run ifconfig, it tells us my IP address is 10.10.16.201. My hardware address is this FC address, this long in hexadecimal, 12 digits, 48-bit address. We use the hardware address for communications inside the LAN. So whenever your wired interface needs to send to another computer in this LAN, say in this room, then the source address will be your hardware address, and the destination address of that frame will be the other person's hardware address. Okay, so the hardware addresses are used by Ethernet protocol, and the source and destination address are set inside the frame that's sent in the LAN. So that's used for internal communications. But if we want to communicate to someone outside of our subnet, that's where IP addresses come in. But in fact, most applications today we use IP addresses, and when I say I want to communicate with 10.10.16.202, for example, so I specify the IP address as the destination, we know it's in the same subnet. Computer 2 is right next to me. For my computer to send a frame to computer 2, it must know the hardware address of computer 2. Okay, so I know as the user the IP address of computer 2, 10.10.16.202, but I don't know, or my software doesn't yet know the hardware address of computer 2. So we have a bit of an issue. How does my computer discover the hardware address of other computers? For example, I want to connect a computer, who have we got? Computer 37. If I want to connect to computer 37, 10.10.16.237, I know its IP address. I need to know the hardware address of computer 37. Does anyone in this room know the hardware address of computer 37? Computer 37, does anyone have the hardware address? That is the IP address 10.10.16.237. Maybe that person will stand up. I want to know the hardware address of computer with IP address 10.10.16.237. Microphone. What's your hardware address?
Hardware FCAA 143902 CD.
Okay, thank you. Now I know the hardware address. Now my computer can send a frame to computer 37 because everything sent across the LAN is sent using the Ethernet protocol, and they must use the hardware addresses to communicate. If I wanted to contact computer, who's at the back, 27, I say, I want to contact computer 27. Anyone out there?
Yep.
Yes, there is. Good. And what do you tell me?
My hardware address.
Okay.
FC.
Okay, so she'll tell me the hardware address, and there's no need to read it out. Good. So the idea is that for my computer to contact anyone, I must first learn their hardware address. And the way that I did it is I yelled out to the whole class saying, who has this IP address? Who is computer 10.10.16.227? And that computer who is that responded to me saying, I am computer 27 and my hardware address is this. Of course, we don't do that manually. That must happen automatically. Whenever I try and contact a particular computer, if I try to secure shell into computer 27, I press enter. The time from when I press enter until when I log in, automatically in the background, something discovered the hardware address of computer 27. Okay, so there's a protocol that operates really in the background. Whenever we want to contact someone by IP address, this protocol goes and finds the hardware address. The protocol is called the Address Resolution Protocol. ARP. We will see this in the next lab. We'll see how it works. But for today, there's also a command called ARP, the Address Resolution Protocol. And it shows me from my computer's perspective, who do I currently know about? Who have I asked recently? If I run it, it shows me a table. And it doesn't look so good on my output. I'll run it again. We'll run it here in a slightly better output. There are two main columns. There are multiple columns there, but two columns of interest. We pipe it into less. The address, which is the network address, and the hardware address. The ether type, or the hardware type, is almost always the same, Ethernet. But look at these two columns. The address is the name of the computer that I want to contact, and this is the hardware address. Now note that the addresses, some are IP addresses, some are the nicknames. We've given each computer a nickname. And you see the pattern, I think, netlab followed by the computer number. Now, I don't like nicknames so much, so I'd prefer to use this command without nicknames. And many networking commands, if you don't want the nickname, add the -n option. And you'll see me do that a lot with different commands, and I'll not explain it. But that means show me the raw address, not the nickname. So let's run it again with the -n option. And it shows that my computer recently has been in communication with 10.10.16.220, and the protocol ARP automatically learned that the hardware address for that computer was this one. So this is a table of the recent ones we've learned. And when you run the command, you'll probably see your table is much smaller. The reason I've got many entries here is because you've all logged into my computer. You're all communicating with me now. You use Secure Shell to communicate to my computer, to connect. So I know your hardware address already. But when you run it on another computer, if I log into another computer, I'm on computer 10 now. Computer 10 currently knows about 4 other computers. IP address .1, .231, 201, 236, and it knows their hardware addresses. So over time, that may change. It's like a cache of the most recent ones that we've communicated with. Over a few minutes, if you don't contact that computer, it disappears. So ARP as the command shows me the most recent, or the hardware address of the computers I've recently communicated with. ARP, the protocol, gathers that information. It's running whenever you try to contact another computer by IP address, ARP runs, and it works by yelling out who has this IP address and that computer responding. The yelling out in a network terms is a broadcast. We'll see the protocol work later, but just remember the ARP command shows you those hardware addresses. So then you can see about your friends and see what their hardware addresses are. Let's go back. So maybe just contact a few other computers and see that table change. So currently my table has those 4. If I ping another computer, and we haven't studied ping yet, but you've seen me use it in a number of other cases, or maybe in the lectures. If I ping another computer, 235, and then stop that and look at ARP again, now I see 235s in the list. Before, I didn't know the hardware address of 235. When I pinged or tried to communicate with computer with IP address 235, ARP went to work, it learnt the hardware address, and we can see that in the output here, now 235's in the table. Over time, that table will get smaller. It takes, I think, a couple of minutes for the entry to be removed from the table if we don't contact that computer. So just see your ARP table grow by contacting a few other computers. Either secure shell into them, ping them, or use wget or access the web page. We've seen netstat gives us some statistics if we use the -s option. So netstat, the network's data showing statistics. What are the 2 transport protocols which are common? Everyone should remember the 2 common transport protocols, and you'll see here TCP and UDP. Right? TCP is very common. Most of the applications we're using in this lab use TCP. When we secure a shell into another computer, access a website, you send emails. TCP, before we send data, we set up connections. So here the stats say there are 7 active connection openings, 72 passive. Active is usually when we initiate the connection open. Passive when someone connects to us. Your stats will be different from mine on your computer. So TCP, we set up a connection, transfer data, and then close the connection. So one thing we commonly want to look at is what connections do we currently have open? Who's currently connected to us? And in fact, netstat can show that. If you run the command, and I'll do it here so I can zoom in a bit better, and on computer 10, netstat -t shows us the TCP connections. And I'm going to use, again, the -n because I want the no nicknames. I want the raw addresses. The -t option, show me the TCP connections, the current ones. And here, in this case, I'm on computer 10 here. It shows me there is 1 connection. So netstat -t, show me the current TCP or the active internet connections. And the 2 Well, 3 columns of interest are the local address, foreign address, and state. The protocol is TCP because I set the -T option. Local address, note that it has 2 addresses. There's an IP address, that's me, 10.10.16.210, because I'm actually logged into computer 10 now, and a port number, port 22. And the foreign address is another computer, 10.10.16.201, and a port number as well. So the addresses contain both IP address and port number, and the state says that this connection is currently established. We're connected right now. The state may change. Normally what happens when you finished communicating, the connection closes, but it actually stays temporarily open for a couple of minutes, so then it fully closes. You'll see some other states like time wait here. If I connect to another computer, I'm currently on computer 10. How do I connect to another computer? What's wget do? Everyone remember? Get a web page. And every computer in this lab runs a web server, so I can get the web page of computer 221. wget just downloads the web page. From computer 21, I'm going to visit their website, save the file to index.html in this case. So I don't want to show you the page, I just want to download it. wget does that. And now if we look at netstat, I've got the original connection between computer 10 and computer 1, and there was another connection from computer 10 to computer 21, because wget uses HTTP to access a website, and HTTP uses TCP as the transport protocol. So this shows me I recently, computer 10, using port 53463, contacted computer 21 on port 80. The state is time wait. The connection is not established. This normally means that we established the connection, we transferred some data, we closed the connection, and then we're just waiting for it to fully close. We wait a couple of minutes before, just in case there's some extra communications. So time wait means we're waiting for it to close. After I think a couple of minutes, or not so long, it disappears. So you see the connection from my computer to computer 21 is no longer there. It's fully closed now. So netstat -T gives us some information about our current connections, TCP connections. We can often estimate or guess what application is being used by the port numbers. Port 22. What server uses port 22? Easy one. What server uses port 80? HTTP, or a web server. So HTTP uses port 80. So this line tells me I connected to a web server. The 53463 port is allocated by the operating system to my browser, wget, but port 80 is usually fixed and used by a web server. So when I see this, I know I recently contacted a web server. Here, what's this data? I'm still connected to port 22. What do you think port 22 is? SSH. Remember, I secured shell into another computer. There's a secure shell server. Web server uses port 80. Secure shell uses port 22. Good ones to remember. If you can't remember them, there's a file on your computer that reminds you. It's in the etc directory. It's called services. Have a look in the file. It's just a text file that lists the port numbers and the server names or the services. Have a look in /etc services. So when there's a quiz question, what is the port number for FTP or for SMTP, you'll look up this file and see the answer. We see SSH is port 22. HTTP port 80. And some others you may recognize over time. 443 is down here somewhere. HTTPS when we connect to a secure web server. Different port numbers used. While we're looking at text files, let's look at one other. /etc/protocols. What's the protocol number for TCP? What is the protocol number for UDP and others? Look in the file and it will remind you. The protocol number, a list in the protocols file. IP is 0, ICMP is 1, TCP is 6, UDP is 17. They're common ones we'll see. Transport protocols are given numbers. But there are many others here as well. Those files are typically on Linux operating systems in that location so that software can look them up. So what you should do is contact some other computers, either secure shell into them, access their websites, and then look at netstat -t to see the connections. Netstat -t. What if I access the ICT server? Using my web browser links, because I'm logged into computer 10, I don't have a graphical interface. So I'm sitting at my computer, but I'm actually secure shell into computer 10. I can't open Firefox, not without other settings, so I'll use my text-based web browser, links, access ICT, and it takes me to the ICT server. We visit Moodle. Do I want to accept cookies? Yes, let's allow that. And now I'm on the Moodle website. Now let's quit. Yes, I'm sure. And look at our connections. My connection disappeared there. In that case, links closed the connection immediately after I ended. So not a good example. Even better. Let's try this one. Use wget. That's better. Try it again. Links closed the connection and deleted the connection state straight away. So that wasn't a good example. But wget, download the ICT web page. Look at netstat. And I see in there, because I just did it twice, there were 2 connections to the ICT server. I know that the ICT server has a special IP address or a local IP address of 10.10.6.11. It's just upstairs on the 3rd floor, the server. So these were my 2 connections to the ICT server. If I connect again, then there's another connection. And they're in the time wait state because the connection's been closed, but it's waiting for a couple of minutes for it to fully close. Whereas with links, it fully closed it straight away, so I didn't see it. So contact some different servers and see the output with netstat. So we're trying to look at the TCP connections and using netstat to look at that. So we're going to use netcat to create a simple TCP connection. And I'm going to do it in some different terminals so that we can see it all at the same time. So on computer 10, so the blue one is computer 10, the green one is 13. Okay, 10 and 13, I'm logged into those. Computer 10, down here I'll start the netcat server. To start netcat in server mode, -L. Tell the netcat software to listen. And we need to choose a port. And the port is a 16-bit number, so it goes up to about 65,000. In practice, we need to choose a number greater than 1,023. So, and less than 65,000. Here's a simple one. So this tells my netcat software to listen. Listen in on port 12345. And it's listening now. And still on computer 10, now I'll use netstat. Let's show me the TCP connections, and let's show me the ones which are listening on this computer. And there's a number of essentially servers running on my computer. There's a number of pieces of software listening on my computer. Well, we do recognize this one. There's some software on my computer, and it's listening on port 12345. And that's the netcat software. That's what I noticed there. Now the other information, maybe the address information, this all zeros means anyone is listening for any particular address. That is, anyone can connect to it. We notice some other ports. If we look through the ports here, here's port 22. There's some software running on my computer listening on port 22. What is that software? It's the secure shell server. Every computer, when they boot up, that automatically starts a secure shell server. It's called the SSH daemon. SSHD is the software. So there's a secure shell server. Now there's another entry for 22 here. This is for IPv6 connections, IP version 6. This is for IP version 4. But the key thing to point, or to realize from the output are the port numbers here. Sometimes there's both IPv4 and IP version 6. Sometimes there's just IPv6, which covers IP version 4. A bit confusing. Note just the port numbers. Port 80, every computer's running a web server. Port 22, every computer's running a secure shell server. Here's my computer running the netcat server. What about the others? 3306, what is it? When you saw it, did you look in the services file for 3306? MySQL. We're running the MySQL database server on these computers, so it's listening there. Now, the slight difference, it's listening only on the local, the special loopback address, meaning you cannot connect to my MySQL server from your computer. You must be on my computer to connect to my MySQL server. So that's the difference here. The all zeros means anyone can connect. This one means you have to be on my computer to connect to my server. So you can't communicate across the internet. 631 is the internet printing protocol. It's for communicating with a printer. 25 is for email. This is just for local email delivery, not for out on the internet. And I think that's covered them all. So there's some software running on your computer that listens. My netcat server is still running, so now I go to computer 13 and I connect 210. I would connect to the IP address, computer 10, port number, send my message, check the output of netstat, and I see that computer 13 is connected to computer 10. The connection is established. They're still connected. Netcat uses TCP by default. Foreign address is listening on port 12345. And my netcat client, when I started it, was given the port 47990. The operating system gave it to it. We don't do it as the user. So this shows the active connections or the current connections. If you add the -L, you show the servers listening. One thing you may have noticed, the server's still there. I can still send back. But if we look at the listening connections, it's no longer there. That is, there's no longer a listening connection on port 1, 2, 3, 4, 5. That is because netcat is a very, very simple server. As soon as someone connects to it, it's no longer listening for others, it's just communicating with that one that connects. So you can't have multiple people connect to the netcat server at the same time. Real servers, normally when someone connects, it creates a child process to deal with that client and then listens for more connections. That's why all of you can log into my secure shell server. I've got one secure shell server running. Whenever you connect, it creates a copy of itself and then waits for the next person to connect. We'll see that when we look at web servers later. So from netstat -T, you can see information about current connections. Add the -L and you can see those which are listening. Those listening is very useful to know what servers are running on your computer, because that may be a potential security flaw in that if there's a server running on your computer, then others outside may be able to connect to your server and do things. So that's useful to know what's running on your computer. When we close, I close the server, the client's closed, the connection was closed then. So I close the connection and it's not even in a time wait state because we haven't communicated. So you know what about applications communicating using netstat -T. We've seen netstat -S, show me statistics, -T, show me TCP connections. If you read the man page for netstat, there are many, many different options. TCP connections, you can show about UDP, you can show listening, you can show routing information, interface information, statistics and others. All right, so it does a lot. Let's do a couple more. Netstat -I, and I'll pipe it into less. Show me something about the interfaces and some statistics. Doesn't come up very well. The command netstat -I. Some statistics about my interfaces. Right, so my ETH0, 1 and 2 and some of the data of packets received okay, transmitted okay and so on. Netstat -R shows me the routing table. And I should have did it with the -N option to show no nicknames. It was a bit slow without it. But the routing table, if we look at the first two columns, gives me two entries and it says, look at the last column maybe first, to reach anyone on network 10.10.16.0, we know that network address from our first task. To reach anyone on this subnet, there is no gateway, send direct. It doesn't make sense to send to a router if they're on the same subnet as me. A gateway also means router. The first row is for anyone else, send to the router or gateway 10.10.16.1. So if I want to communicate with anyone that starts with 10.10.16, then send direct to them in the LAN. If I want to communicate with someone else, maybe the Google website, Facebook, then the default action is to send to the gateway 10.10.16.1. So we say 10.10.16.1 is my default router or default gateway. It's a computer upstairs on the 3rd floor. So that's a routing table. We will see and modify the routing table with commands in another lab. Today we're just looking at the information. Another way to see that is using the route command. Before we do it, netstat -r-n shows the no nicknames, the raw addresses. And it's generally faster because it doesn't have to look up and find the nicknames. To see the routing table, you can also use route. Route -n shows exactly the same information. We will commonly use the route command to see the routing table, and we'll also modify the routing table using the route command. Netstat just shows us. Netstat -r or the route command are effectively the same from our purposes.